I built a little trackway of mud, and then I offered the bears either applesauce or maple syrup to have them walk across this mud, and then looked at their footprints. So took casts of those and scanned them and looked at how they walk and what do they do when they do that. It's adorable.
This is Origin Stories, the Leakey Foundation podcast. I'm Meredith Johnson, and the person bribing baby bears is Dr. Ellison McNutt. She's a biological anthropologist and comparative anatomist at the Ohio University Heritage College of Osteopathic Medicine. Our story today is about why she was coaxing those bears to walk through mud, and how Ellie and her colleagues solved a decades-old mystery about one of the most fascinating discoveries in the history of science, the Laitoli Footprints. These are fossilized footprints discovered in the 1970s by Mary Leakey at a site called Laetoli in Tanzania in East Africa. There are thousands of prints at Laetoli, left behind by creatures ranging from millipedes to elephants. And among them, there are 3 trackways of prints that are different. The really famous ones, made up of 54 footprints that were clearly human-like. That one's called Trackway G. There's Trackway S, found more recently. And then there's Trackway A, 5 strange prints that scientists didn't know what to make of when they were first discovered. Those prints were all but forgotten until Ellie came along to uncover the secret story that was hidden in the mud of Laetoli for more than 3 million years.
Hands down, Laetoli is one of the most important paleoanthropological discoveries ever made. And the idea that there could be 3.66 million year old prints that just managed to survive for that long is really amazing. I think that they capture folks in a way that almost nothing else does in the fossil record.
Laetoli is a landmark discovery that shed light on one of the most distinctive things about human beings, the strange way we move around.
It's one of the really early things that sets our whole lineage apart from other animals. So what makes us human? One of the big things is that we stand upright and walk on 2 legs.
Scientists have always wanted to know how, when, and why we started walking upright. Fossil bones can tell part of the story, but the discovery of the Laetoli footprints in the 1970s completely transformed our understanding of the origins of upright walking and showed that it developed very early in our evolution, much earlier than scientists had thought.
Laetoli is unequivocal. You have upright, striding hominins at 3.6 million years ago. They are moving like we do. And so it was sort of an amazing moment to have not only, we know that that's there, but it's there and it's that old.
Laetoli was an unexpected discovery, and it came at a time in the 1970s when paleoanthropology discoveries were being made across East Africa in rapid succession, shaking up what scientists thought they knew about our origin story. In 1972, Bernard Ngenyo found 1.9 million year old Homo habilis fossils at Lake Turkana in Kenya. The spectacular skeleton of Lucy was found in Hadar, Ethiopia in 1974, establishing the fact that a small-brained relative, Australopithecus afarensis, was living in the African Rift Valley about 3 million years ago. And later in 1974, Mary Leakey also found afarensis fossils over 1,000 miles away at Laetoli in Tanzania, showing that Lucy's species lived there too, and had the capacity to spread over great distances. There was this big, thrilling burst in knowledge about the early members of our family. And so in 1976, Mary Leakey put a big team together to go back to Laetoli to look for more fossils.
And, as you do when you're out in the field, sometimes you get bored. And when they got bored, the group decided to have a dung fight. So they just started picking up elephant dung and frisbeeing it at one another. And at one point, Andrew Hill hit the deck trying to dodge said dung.
Andrew Hill was a paleoanthropologist who had just finished his PhD. As he scrambled on the ground for more elephant poo to throw at his esteemed colleagues, he saw some impressions that he recognized as fossilized impressions of raindrops. And he knew what they were because he'd been reading a really old geology book with illustrations of raindrops in the mud. So they called an immediate halt to the dung fight.
And then they ended up finding this sort of tuft layer where all these fabulous footprints are. And there are footprints from a number of different animals. There's elephants, there's various kinds of antelopes, there's rabbits, there's thousands of prints of various things.
The prints were preserved by a chance combination of events. First, a volcano erupted, blanketing the area of Laetoli in a thick layer of ash. Soon after that, it rained, so all that ash became mud.
People kind of have in their mind, if they imagine a volcano exploding, something sort of Pompeii-like and terrifying. It clearly wasn't that awful because lots of animals still were hanging out there. So it's probably an uncomfortable place to be, but it isn't kind of the fiery nonsense you probably have in mind. I certainly had the first time I heard that. So it threw down this layer of mud that then lots of animals crossed and made their footprints in, as is pretty standard for mud. But what was a unique moment is then that volcano exploded again fairly quickly, buried those prints under another layer of ash, and that sort of sandwiched them in this sort of protective layer so they didn't get destroyed by rain or any of these things.
The team got to work excavating the site, which they called Site A. As they worked, Mary Leakey told the team to keep their eyes out for possible hominin footprints among all the prints from raindrops, rabbits, rhinos, and birds. And after a little while, they found one small set, just 5 prints among the thousands, that looked quite peculiar. This was trackway A.
They saw them, and Mary looked at them and realized they were a little odd, but they were distinctly upright. So there isn't any evidence of an animal sort of walking for a couple steps, going down onto all fours and coming back up. And they have what's called cross-stepping.
Cross-stepping means that whatever or whoever left these prints was crossing one foot in front of the other as it walked forward, like a fashion model on the runway. And even though that's kind of strange, Mary Leakey couldn't rule out the possibility that the prints in trackway A were left by a hominin, just one that walked completely differently than we do.
They seemed like they're striding, and Mary was like, all right, these look like they could be a human, but they sort of don't match.
40 years ago, when these prints were found, we didn't have anywhere near the fossil record that we have now. But we did have foot bones from Lucy, Australopithecus afarensis, and we knew that species lived in Laetoli when the footprints were made, because Mary Leakey had found fossils there. And because the prevailing thought at the time was that there was only one hominin species alive at any given point, Lucy's species was the only suspect. But the prints of trackway A didn't match with Lucy's foot bones at all, leaving the scientists with a big question.
Well, what else could it be? And the sort of logical choice, and this is a reasonable choice, is a bear. And sometimes people go, bears in Africa, because they're not used to that. But there were bears that lived in Africa about that age. And these are quite big bears. These bears are in the realm of sort of grizzly bear, polar bear size things. So this would be quite a small juvenile bear walking. But if you've ever seen a bear stand up and walk on 2 legs, they do kind of look like a dude in a bear suit. They're actually quite compelling in how they do it. So at the time, what is the next logical choice if it's not a hominin? Well, maybe it's a bear.
If you look at the footprints from a bear's back feet, they actually do look fairly human-like. They're bigger, their proportions are a little odd, but they don't always leave claw marks. The other reason a bear was a good answer at the time is that the way bears' toes compare to human toes could account for that model walk, cross-stepping, in the strange prints of trackway A.
We have a very large first digit. Our big toes are big. That's why we call them that. And then our next couple toes are all much smaller. Whereas in a bear, the big toe is the 5th. It's their pinky is actually the large digit, and everybody else is more similar size to one another. And so that weird cross-stepping that he didn't quite understand what to do with makes a lot more sense. If it's not cross-stepping, it's actually a bear. And so instead of being a left hominin print, it's a right bear print, and they aren't cross-stepping at all.
When Mary Leakey's team came back to the site 2 years later in 1978, they found what people think of as the Laitoli footprints. Trackway G, an 80-foot-long track made up of 54 clearly hominin footprints. Those prints did match Lucy's feet.
There's sort of a beautiful matchup between them. So in that way, they became a lot more the star of the show because they were a lot easier to understand. We sort of had our Cinderella slipper and foot moment. They had a good match, whereas A was very strange.
Trackway A faded into obscurity once G was found. The 54 prints of Trackway G were made by at least 3 individuals who were walking close together, heading north. One was larger than the other, and they were walking close together. You can imagine they might have been a couple. A third individual is following close behind, so those prints are inside the other prints.
The smaller individual of the Laetoli G prints has, it looks like a limp going on. And so you have lots of imaginary moments of were you walking arm in arm? Did you're walking beside each other, and they have a moment where the kind of footprints do a little, they paused and sort of looked at something and then kind of kept going.
The little pause in their steps through the mud is unlike anything else preserved in the fossil record.
So, those are things that we can't, as scientists, we can't know for sure what's happening there. But as people, I think they stick in our brains and in our hearts very much so, because we have that sort of emotional interpretation and connection to them. So Laetoli is an amazing site for that for a number of reasons.
Amazing might be an understatement. Laetoli is spectacular, but decades later, Trackway A and the bear question had been forgotten but never solved.
I just cut into bears, and that's why A came back up.
So around 40 years after the discovery of Trackway A, Ellie was working on her dissertation. And as part of her work, she was looking at all sorts of different creatures, including bears, to try to understand how the way animals move might shape their bones.
That's one of the ways we sort of put together the past. And so bears are a cool analogy. They're very similar to apes, but they're distantly related to us. So if you want to say your bone is shaped this way because of what you do and not because of who you are, it's nice to look at things that are not closely related to you but do similar things.
As Ellie dug through the scientific literature, she happened across something that grabbed her attention. The research papers from the 1970s, making the case that the prints of Trackway A at Laetoli were made by a young bear walking upright on 2 legs. The perfect intersection of her interest in bears and the origins of upright walking.
And I had kind of a moment of a juvenile bear walking by itself alone in a place where they haven't found bears for another 40 years. So at the time when they said bear in 1970, they hadn't found any bear fossils. But that's not impossible. We don't always find fossils for an animal that lived in a place. But usually there's a good reason, something like a bird.
So you may end up with bird footprints at a fossil site, but no birds, because the birds have flown away.
But there isn't a good reason why that would be true for bears. And now we've had another 40 years of trying to have a chance of finding a bear fossil, and there isn't one there. And so I was like, all right, I don't believe this is possible to be a bear. These prints look odd. I mean, Mary Leakey sort of said that these are kind of strange. And it's like, they are strange. I don't know that they're for sure not a bear, but I have the chance to go look at that. And they don't look like the G prints. So, something is going on.
That's when she decided to reopen this 40-year-old mystery about 3 million-year-old footprints. Something didn't seem right, and Ellie was in a perfect position to figure it out because right near her university was a place called the Killam Bear Center. The center's director, Ben Killam, has been studying wild bears for decades, but his center also takes in orphaned black bear cubs.
So these are bears that have had, for example, mom has been hit by a car, or maybe she got killed by hunting, or, sometimes bears abandon their cubs due to the, hardship of whatever's going on there. And little bears cannot survive on their own. They kind of need assistance to make it through that first year and a half or so. And so at the time, they happened to have a couple bears about the right size. Their feet are very similar in size to what we see at Laetoli A.
This is where Ellie made the little trackway and used applesauce and maple syrup to entice the bears to walk across the mud. And when she studied the prints they left, they didn't match up with the images or the measurements of the prints at Trackway A. And the bears moved differently than whatever made the fossil prints.
So when the little bears stand up, they toddle side to side. They just don't have the ability to be quite as striding forward as a human is, and they don't have the balance to ever cross their foot completely in front of them. So that was sort of one of the things that went, okay, it doesn't seem at all likely that bears could do this.
In addition to that creative and adorable bit of science with the baby bears, Ellie looked at the behavioral data on wild bears that Dr. Killam of the Bear Center had been collecting for over 20 years. And she said, okay, American black bears seem fairly bipedal in the wild. You see them stand up and do things, but how often does a bear stand on the ground and walk 4 or more steps, which is what a bear would have had to have done to leave those prints at Laetoli.
And the chances of a bear doing that are 0.003%. They really don't do it very often. Most of the time they either stand up to just display it one another, or they'll stand up and hold onto a tree like I'm going to eat a piece of it. But they very rarely walk anywhere. And so this is an unusual behavior for a bear. The chances of capturing that would be incredibly tiny.
With all of that, Ellie had enough evidence to rule out the possibility that these tracks were made by bears. But if it wasn't a bear, what was it? To answer that question, Ellie needed a team, because Ellie had just been looking at drawings and photos of Trackway A. The original casts had been lost, and the footprints had been reburied decades before.
So one of the things that was missing when they did the initial discovery, turns out they didn't get a nice full complete excavation of the prints themselves.
So Ellie and her advisor, Leakey Foundation grantee Jeremy De Silva, called on their colleague, Dr. Charles Musiba.
Scientists will always have to go back to look at what we have done in the past and try to see what else can we learn. So when Jeremy De Silva approached me and said, Charles, do you think we can go back to the A print and do you think they are still around? I said, oh yeah, they are still around.
Dr. Musiba is a paleoecologist at the University of Colorado in Denver, and he's a Leakey Foundation grantee. He was mentored by Mary Leakey when he was a student in Tanzania, and now he leads research at Laetoli. So he knows Laetoli better than almost anyone alive, and fortunately, he still had Mary Leakey's hand-drawn map of Site A.
I have actually sort of laminated it and framed it because it's so valuable. And people look at me and say, they're just handwritten maps. I'm like, yes, but to scale, that's the one thing, right? And so it's just one of those treasures. Even though we knew where the site is, we use them when we actually, every time we reopen the footprints, we have those maps with us. They help to guide us. They are like our roadmap.
When Mary Leakey found Laetoli, it was a new kind of discovery for paleoanthropology. The community didn't know what to do or how to preserve the fragile fossil footprints that couldn't be easily packed up and moved to a museum. So Mary was really on her own.
And I said, so how did you think about conserving them? And she said, Charles, the only thing I could think of was covering them back.
She covered them back up with volcanic ash and soil from the site, and she piled rocks on top to try to discourage animals from trampling the footprints. So in 2019, with Mary Leakey's maps in hand, Charles led a team to re-excavate Trackway A to see if they could find more clues and figure out just who had left these prints behind. Unlike the team that first uncovered these prints, Charles and the other scientists were equipped with 21st century technology. But first, they had to see if the footprints were still intact, decades after they were discovered.
I mean, they were still in a very good shape. And so, which suggests sometimes that nature maybe takes care of, of some of these treasures, like those footprints.
They carefully re-excavated the prints, they did 3D laser scanning, and took highly detailed photos and measurements of all the prints in the trackway. Then Ellie and her research partners compared the measurements of the Trackway A prints to the other Laetoli tracks, to fossil prints from other places, to hominin feet. They also compared them to modern prints of humans, bears, and chimps.
Interestingly, when we look inside these prints, they just visually don't quite match up.
They didn't match up with bears, chimps, or Afarensis, Lucy species, or any known hominin species. But they were definitely left by a hominin.
Now, the frustrating thing is then the next question I always get is, well, then who are they? And I can't tell you. There are some candidates. So obviously that one of the options is that they belong to a completely different species that we haven't discovered yet.
The evidence that Ellie and Charles and their team uncovered now suggests that a whole other species of hominin was walking alongside Lucy's species in the muddy volcanic ash of Laetoli at the same time.
Within days, within hours, who knows? So what does this information tell us? That's the question which we should be asking. What does it mean?
So the coolest thing about this is obviously it's one more opportunity to say that being up on two legs is really old in our lineage. But it's also a pretty fabulous moment because it is an unequivocal moment where there are two hominin species hanging out in the same place.
Usually when scientists say hominins lived at the same time, they're talking about a scale of thousands of years or tens of thousands of years. This helps us understand the general time period in which our hominin ancestors were living, but it doesn't give a clear picture of who is interacting with who, because two fossils found at the same site in the same soil may come from individuals who lived thousands of years apart.
But fossil footprints are made on scales of hours to days. So we absolutely know that they were in the same place at the same time. The Laetoli A hominin could have, looked across the couple kilometers between that and where the G prints and seen an Afarensis walk. And so that is what makes it by far the coolest moment, is that they're there together.
Lucy's species wasn't alone on the landscape. This is true for most other animals, but not for humans today. Since the Neanderthals disappeared, we've had this solitary existence that's led us to believe that most of our lineage's history was similarly lonely. Knowing that isn't true opens up a world of possibilities for understanding our past.
I'm a big believer that we are just scratching the surface to understanding who we are.
Charles knows that Laetoli has a lot more to tell us about our ancestors and the world they lived in. The team plans to return to Laetoli this summer if it's possible, to see if they can find more prints that expand the trackway in both directions, or maybe even find some fossils that match the prints. And as a paleoecologist, Charles is thinking about more than just hominins.
So the other thing about Laetoli is that there are a lot of other animal trackway sites which are equally important, in my opinion. We have not done even a good work to document them properly, and we are losing them. Those actually we are losing it very fast. And to me, that's a snapshot. You're talking about a snapshot of what happened at a particular time 3.6 million years ago, where you have guinea fowls, you have primates, you have antelopes, you have elephants, you have hyenas, you have lions walking, and they are all walking towards the same direction. The question is, what are they doing? They're part of the story. Our hominins were just not alone on that particular landscape. They were part of a community of organisms, right? Which made that part as a dynamic ecosystem. And to me, that story needs to be told.
The stories of Laetoli, those told and yet to be told, will continue to expand our understanding of who we are and how we came to be human. And they show how science is a continuous process of questioning what we think we know.
It's a kind of a triumph of the scientific method. And, someday someone will do this to me, but the ability to go back and say, okay, I know more now than we knew then. I have more technology now to understand it than we knew then. And in 40 years, someone will do that to something else I've said, and that will be amazing too. And that's sort of the collaborative and learning nature of science, is that you sort of do the best with what you can. And then as we know more and have more tools to answer them, kind of go the next step.
Thanks to Dr. Ellison McNutt and Dr. Charles Musiba for sharing their work. There are links in your show notes to learn more about them and their research. This episode was sponsored by Jim Carty and Pat Randall. Jim is a longtime supporter of the Leakey Foundation, who actually volunteered to work at Laetoli in the 1980s to help figure out a way to preserve the Laitoli Footprints. He did a wonderful study to explore the possibility of moving the prints to a museum or constructing an on-site shelter. He shared an amazing binder full of photos and letters with our team, and I'm going to share some of his photos on our website, leakeyfoundation.org. Thank you so much to Jim Carty and Pat Randall for making this episode possible. Now it's time to announce our book giveaway winners. Congratulations to Lori Yule, Travis Grauer, and listener I'm Rock Palm. You've all won a copy of Discovering Us, 50 Great Discoveries in Human Origins by Evan Haddingham. Thanks to everyone who filled out our audience survey and entered to win. I learned so much from all your thoughtful responses that I'm going to extend the contest and give away 3 more books. If you've already filled out the survey, you'll have another chance to win. If you haven't yet filled it out, now's the time. The next winners will be randomly selected on May 23rd, 2022. The link is in your show notes. Origin Stories is a project of the Leakey Foundation, a nonprofit dedicated to funding human origins research and sharing discoveries. You can support this show and the science we talk about by making a donation to the Leakey Foundation today. All donations will be quadruple matched thanks to Jeannie Newman and the Ann and Gordon Getty Foundation. This episode was produced and sound designed by Ray Pang. Our editor is Audrey Quinn. We'll be back next month with another episode. Thanks for listening.